Good morning, good afternoon, and welcome back after Thanksgiving. Guys, we're going to work through lesson 8 this week. We're going to do it in 2 days because it's a really big, important, and kind of complicated lesson. So we'll take 2 days on it. So we'll do the first part today and the second part tomorrow. And we'll talk about, kind of wrap up on Wednesday. The first thing we have is this, this notice and wonder question, and I do want you to answer that. All right, I'm going to check it in your book when you turn it in. So this is in your book on page, let me find it here, page 63 in your book. Okay, it says, do you see a pattern? What predictions can you make about future rectangles in the set if your pattern continues? Okay, so make some notes there. What patterns do you see? What can you predict about future pictures? All right, this lesson or this part as we turn the page is talking about using an equation to come up with values. And we haven't done much of that this year, so let's work this out. It says, the other day you worked with converting meters, centimeters, and millimeters, and we did that either in lesson 6 or lesson 7. Here are some more unit conversions. So the first one says, use the equation F equals 9 over 5C plus 32, where F represents the degrees Fahrenheit and C represents degrees Celsius to complete the table. So this is the formula that scientists, that people use, meteorologists, use to convert Celsius temperatures to Fahrenheit temperatures. And this is saying F represents the degrees Fahrenheit, C represents the degrees Celsius. So let's see what's in this table that they've given us. It says temperature in Celsius is in the left and temperature in Fahrenheit is in the right. So the Fahrenheit is depending on what the Celsius is. So they've given us this equation. F is equal to 9/5 times the Celsius temperature, and then we're going to add 32. Our order of operations, the PEMDAS you probably talked about in the last couple of years, says to multiply first. So the first thing we would do in this little equation is to multiply these two things together, and then we would add 32. So this table is telling us that our temperature Celsius, that C value, is 20. So we're going to put 20 in for C. We're going to do 9/5 times that value times 20, and then we're going to add 32. Now 9/5 times 20 may be a little complicated, especially when we get these different numbers in here, but we could change that to a decimal. That might be easier. 1.8 times 20. And then we add 32. And we can do that by hand, or if you want to take out your calculator, we could do that. We're going to fill in this table. So if I do 1.8 times 20, I get 36. And then after that, I'm going to add the 32 in. So I get a total of, when the temperature Celsius is 20 degrees, the temperature Fahrenheit is 68 degrees. That's my 36 plus the 32. All right, I want you to do the same thing for 4. So you'll do 1.8 times 4, and then add that 32. And then you'll do 1.8 times 175, and add that 32. So fill in those values in the table. Hit pause, fill in those values. And now the second part of the page says, use this equation, C equals 2.54n, where C represents the length in centimeters and n represents the length in inches to complete the table. So this is the conversion from inches to centimeters. Every inch has 2.54 centimeters in it. So if we know the number of inches, we can find out the number of centimeters. And our equation is that the centimeters is equal to 2.54 times the number of inches. So for this first column, we know that the number of inches is 10. So our centimeters will equal 2.54 times that 10. We multiply. I know how to multiply by 10. I move that decimal point over. That would be 25.4 centimeters. And then we'll do the same thing for when n is 8. 2.54 times 8. And then the same thing for when n is 3.5. 2.54 times 3.5, we could do 3.5 for 3.5. So fill out that table as well for me. Hit pause, calculate those values, and fill them in. And now the important part of this lesson is the question is, are these proportional relationships? Explain why or why not. And what we've learned is that we're going to take this value and divide it by this value. So this is our y, this is our x. Find out what y divided by x is, or we could write y over x. Divide each one of those and write the answer over here. And you're going to do the same thing for the top of the page as well. Divide, divide, divide. Write the answer over here for me so we can see. And then decide proportional relationship or not. And you remember what we talked about prior to this week was that if when we divide we always get the same answer, it's a proportional relationship. If when we divide we don't get the same answer, it's not a proportional relationship. All right, so figure those out for me and answer that question number 3. Okay, as we turn to this next part, this is a little bit long, and it's why I wanted to break the lesson down into 2 parts. A little bit of geometry here. Okay, so what we have is cubes. Here it says, here are some cubes with different side lengths. Complete each table. Be prepared to explain your reasoning. So cubes are not just like a box of cereal. A cube, very specifically, what we know about a cube is that all of the sides are exactly the same length. So if I were to sketch kind of a cube with invisible sides. So here's the front. We have sides going that way and the back, like you can see in the picture. But also, remember that there are these other sides as well that we can't see because they're in the back of that cube. So we're going to do a little bit of geometry here. The first question is asking, how long is the total edge length of each cube? So what's that's asking is, if I take the edge of that cube and add up all of the different edges, how long is it? So let's see. For that cube, that's 3. I have 3. Let me do this in yellow. 3 this way, 3 this way, 3 this way, 3 this way. And then also 3 going back, 3 going down, 3 going this way, and then another 3 and another 3. So those are the ones that I can see, but then there's another 3 like this, another 3 this way, and another 3 this way. So let's see if we can count up all of those edges. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges to that cube. Okay? So if each one of those edges in my first cube is 3, I would do that 3 12 times, and I could add it up 12 times, or I could multiply 3 times 12 and get my edge length. That would be 36. I want you to do the same thing for an edge length of 5 and do the same thing for an edge length of 9.5. How would we find out that value? And remember, each of these cubes has the same number of edges. Each one has 12 different edges. So fill out that table. Now when you're done, it's saying, what if the length of the side of a cube was S? How would I find out the total edge length? Well, I would do 12 times that S, right? So that's called edge length for that first one. We added up all of the edges. Next question is a little bit different. This next question is about surface area. So surface area is, imagine if you took that cube and you cut along all of the edges and you laid it out flat. So sometimes we call that a net in elementary school. If we cut it open and we laid it out flat, and the question is, what would the area be of all of those little rectangles? Or all of those little, they would be squares in this case because it's a cube. Well, let's see. Because it's a cube, all of those sides are the same size, so that helps us. When we're finding surface area, we take all of the flat sides, all of their areas, and we add them together. So if I look at the front edge of that cube, that's 3 by 3. To find its area, I would multiply. So it's 9 units square on the front of that cube. but it's also 9 units square for each of the other sides as well. How many sides does a cube have? Well, let's see, it has a front and back, it has a top and a bottom, and it has a left and a right. So it has a total of 6 sides. So for that first cube, where its front side has an area of 9, there are 6 of those 9s, giving me a surface area of 54. That's 6 sides times the area of 9. I would do the same thing for the 5. The area of that one of those flat sides would be 25, but there's 6 of them, giving me an area of 150. So 6 times 25. You do the same thing for the 9.5, so hit pause, find out that area for me. And then if I'm looking for, what if the side length is S? Well, it would be 6 times that side times itself, side times side. Sometimes we say side times side as S to the second power. So our little formula would be 6 times S to the second power. That's a little complicated. We haven't done anything like that. Wish we could have done it together in class, but we didn't, so that's okay. All right, we'll do this one last piece, and then we're going to call it a day. It says, what is the volume of each cube? Well, to find a volume, we do length times width times height. Length times width times height. So if the volume, if the side length is 3, its volume would be 3 is the length, 3 is the width, and 3 is the height. 3 times 3 times 3, that's 27. When we talk volume, we actually say units cubed. So if it was centimeters, it would be centimeters to the third power. So do the same thing for me for 5 and for 9.5. We multiply them all together. And again, you can use decimals. So hit pause, use your calculator, fill those out for me. And then what we would say is if the side length is S, that would be S times S times S. Or we write S to the third power. Okay, that's our little formula. All right, and then the last question here, last ones we'll do today. Which of these relationships is proportional? And explain how you know. So we'll do the exact same thing we've always done, right? This divided by this divided by this divided by this. Do we get the same value? This divided by this divided by this divided by this. Do we get the same thing? And for our volume as well. Are any of those relationships proportional? Explain how you know. There's kind of a cool little answer to this question, but we're not going to work on that today. All right, so finish that up. And tomorrow we're going to finish lesson 8. This is, again, it's a big one. It's a little bit complicated, but it's really important. So we'll stop here today. Make sure you do Schoology number 1 is due tonight. All right, thanks, guys. Have a good evening. Bye-bye.